Olive oil mills were used for processing the fruit of olive trees until the appearance of the first steam-powered olive oil presses. Of course, their appearance did not occur uniformly across the region of the North Aegean. For example, according to recordings, in Lesvos there were steam-powered olive oil presses already from the mid-19th century, whereas in Chios, olive oil mills continued functioning almost until the mid-20th century. The olive oil mill presented here has a flat stone base on which rotates a millstone in the shape of a truncated cone. Olives are placed on the stone base under the rotating millstone. In order to rotate, the millstone is supported by a vertical axle, which is fixed to the center of the stone base and to a beam above it, whereas in a different variation, the upper part of the axle rotates freely. The axle is connected to the millstone by a type of wooden crate in the shape of a trapezoid, the one side of which extends beyond the diameter of the stone base. From this projection, they would tie the ropes pulled by an animal, usually a mule, thus turning the stone and crushing the olives. The ropes were tied to the harness of the animal, whereas behind its front legs they would tie a horizontal plank, used for holding back the pressure exercised by the ropes. Sometimes, behind the animal, there would also be a second plank, used for keeping the ropes expanded in order to avoid hurting the animal. On the harness of the animal, they would also tie another rope, connected to a horizontal rod, which was attached to the axle of the olive oil mill. This way, the animal rotated the axle and at the same time was guided along its course without needing the intervention of a guide. Olive oil mills in the shape of a truncated cone seem to have been in use since at least the 18th century and probably from the post-Byzantine period. It seems that the use of a single upright cylindrical millstone started in the mid-19th century, whereas olive oil mills using two cylindrical millstones followed soon after. Furthermore, this transition did not happen uniformly in all regions. In any case, the use of one or two cylindrical millstones in olive oil mills did not bring about significant changes in the olive crushing process. Only the diameter of the stone base was reduced, at least when using one cylindrical millstone, whereas the rim of the stone base would often be elevated, usually by adding an iron hoop, i.e. a ring, in order to counterbalance the decrease in the capacity of olives and of the olive pulp being produced and resulting from the decrease in the diameter of the stone base. The millstone moved with the use of a horizontal axle, which penetrated one or both millstones, and the vertical rotating axle, and jutted out considerably from the bottom millstone, so it could be tied to the animal, moving the whole structure used for crushing olives. Next, workers transferred the olive pulp produced by the crushing process in a wheelbarrow to a tank where it was stored. The compression process at the press followed afterwards. Originally, the press was wooden. Its basis consisted of a wooden beam, known in Chios as the bottom table, on which the compression surface was located. Two vertical beams, the uprights, were supported on it. On the upper part of the uprights, a horizontal wooden beam was battened down, serving as a swivel nut for a large screw, connected to the pressurizer, which exerted pressure on the olive pulp to cause the effusion of olive oil. Olive oil mill workers would then take the olive pulp and place it in coarse bags, usually made of goatskin, which were known as towels in Chios and as feed bags and later envelopes in Lesvos. Then they began the stacking process by placing the towels or feed bags or envelopes on the bottom table and compressing them with the help of the large wooden screw. The screw had two cylindrical through holes in which they would set a wooden manual lever, which moved the screw and the pressurizer downwards, compressing the olive pulp inside the towels or feed bags or envelopes. The lever was initially set in one of the screw holes. When its movement was obstructed by the upright beams, it was moved to the second hole of the screw in order to continue the compression process. During the final phase of the compression, they would also make use of a vertical ground post. This ground post, which could rotate manually, had a rope or chain coiled around it, which was attached to the wooden manual lever. After the first dry compression, there were 2 to 3 additional compression phases. Workers would take the envelopes down from the press and push the olive pulp to the middle of the envelope by hand, and then souse the olive pulp with hot water in order to facilitate the effusion of olive oil. This process was called thermization in Lesvos. Then they placed the olive pulp on the press again and repeated the compression process. Towards the end of the 19th or the beginning of the 20th century, the ground post was replaced by a winch. At the same time, wooden presses were gradually replaced by industrial structures consisting of 2 or 4 vertical beams with parts made of cast iron or iron manufactured mainly in Smyrna, Piraeus, and Thessaloniki. The new presses had a metal disc called a ratchet at the bottom end of a large screw. Above the ratchet sat another metal disc which could move freely around the metal axle of the large screw. This movable disc had a cylindrical socket in a horizontal position on which the wooden manual lever was attached. Its attachment to the ratchet was secured by a metal valve, or actually a safety valve, which penetrated the rotating movable disc and interlocked with the ratchet. The metal valve had an oblique edge, and therefore when the wooden manual lever moved clockwise, squeezing and compressing the olive pulp, the metal valve could follow this movement smoothly, given that its oblique edge was placed according to the direction of the movement, at the same time obstructing any reverse movement, since its longer edge did not allow the reverse movement of the disc attached to the ratchet. This is how they secured the compression process. To complete the reverse process, i.e. the decompression, they placed the metal valve the other way round, with its oblique edge directed toward the new rotation direction of the movable disc. Next, the olive oil would flow into a basin, made of wood or stone with 2 or 3 partitions. The olive oil and water mixture would fill the first partition. Because oil is lighter than water, the oil formed a layer on the surface of the water in the first partition, and through an opening, the oil flowed to the second partition, more or less free of the water. A similar process was repeated from the second to the third partition, given there was a third partition. The olive oil was carried in special metal containers and stored in other metal containers having 1 semicircular and 1 vertical side in order to be loaded more easily on pack animals. In other cases, the olive oil was stored in goatskin bags and then finally stored in large clay jars for household use or transferred to barrels in order to be exported.